In the last few videos, we've been talking about the atmosphere, what it's made of, and how it works. Today we're looking at what happens when the atmosphere is heated. So come along with your favorite hippie and let's learn some stuff! Every movement of the atmosphere begins with one simple fact. Earth is constantly being heated by the sun, but that heat isn't equal. Some parts of the planet receive far more energy than others, and that uneven heating is the root cause of almost all weather. The atmosphere is like a giant engine, and the sun is the fuel source, but the fuel is being poured in unevenly. The sun transfers energy to Earth primarily through radiation. Unlike conduction and convection, radiation doesn't require a medium. Energy travels as electromagnetic waves through the vacuum of space. It's like standing next to a campfire. You feel the heat even though nothing is touching you. The same process heats the Earth from 150 million kilometers away, or 93 million miles. Sunlight strikes the Earth at different angles. Near the equator, sunlight hits more directly, concentrating energy into a smaller area. Near the poles, the same amount of energy is spread over a larger surface. It's like shining a flashlight straight onto a wall versus at an angle. That angled beam isn't dimmer because it's less bright, it's just more stretched. The atmosphere isn't heated directly by the sun very much. Instead, the sun heats the Earth's surface first, then land and water absorb radiation and warm up. That heat is then transferred to the air above through conduction and convection. It's like I've said in previous videos, the atmosphere is like a pot of water being heated on a stove. The heat comes from the bottom, not the top. Something important to remember is land and water respond to sunlight very differently. Land heats up quickly and cools down quickly. Water heats up slowly and cools slowly. This difference creates temperature contrast between continents and oceans. Sand at the beach gets hot by midday. The ocean stays cool well into the afternoon. That contrast is the beginning of coastal winds and monsoon systems. As Earth rotates, different regions move in and out of sunlight, creating day and night. Who would have guessed? But as Earth orbits the sun, different hemispheres receive more direct sunlight, creating seasons. Earth's axis is tilted about 23.5 degrees relative to its orbit. This tilt doesn't really change how far the Earth is from the sun in any meaningful way. Instead, it changes the angle and duration of sunlight received at different altitudes. During the summer in one hemisphere, the sun is higher in the sky, sunlight strikes more directly, and days are shorter. In the winter, the sun is lower in the sky, sun is more spread out, and the days are shorter. It's just geometry. Uneven heating produces temperature differences. Temperature differences produce density differences. Density differences produce pressure differences, and pressure differences produce motion. This is the chain of reaction that drives atmospheric circulation. The sun supplies the energy, Earth's tilt redistributes it a little wonky, and then the atmosphere responds by moving. In the next lesson, we'll look at how that motion organizes itself into large-scale circulation patterns that span the entire planet. Stay nerdy!